Hello grade 12s. In today's lesson we are going to focus our revision on statistics. Now over the last couple of lessons you would have noticed that we are doing questions from past papers, and today once again we will be looking at past paper questions and just focusing on the statistics questions. All right. Now something I'd like to advise you guys to do in your revision practice for the exam is not to try to remember every single formula. Don't memorize your formulae. The key formulae will be given to you on your formula sheet. Rather spend your revision time studying concepts. Now there are a few formulae that you do need to remember, especially for paper 1 when we're talking about volume and surface area and that kind of thing. You do need to remember those formulae, but all of the key formulae that you will need for statistics will be given to you on your formula sheet. All right. And also, if you were to end up in a job that actually requires you to use some sort of statistical technique, often you can just refer to a textbook and look up the formula there. So it's always, we like to encourage learners not to learn things off by heart. But after a long period of learning the same thing and doing the same thing over and over again, you often don't have to look up the formula. All right, but for your guys' studying purposes, for your matric exams, don't waste your time memorizing formulae. All right. Also remember to, as you work through past papers, you need to work through many and varied different types of problems and exercises. You cannot learn statistics or any section in maths by just reading about it. You've got to put pen or pencil to paper and practice your skills repeatedly. In terms of the CAPS breakdown for statistics in the exams, it accounts for plus minus 23 marks in the final exam, and this accounts for about 15% of maths paper 2. Now, in grade 12, the two new sections that you learn in statistics is you learn about regression and you learn about the correlation coefficient. So I first just want to remind you guys, before we start doing our past paper questions, I'd like to remind you guys about regression and then the correlation coefficient. We have gone through this in detail, of course, in previous lessons, but let's just remind ourselves for those of you who may have forgotten what regression is all about. So linear regression is a statistical technique for finding out exactly which linear function best fits a given set of data. We can find out the equation of the regression line by using an algebraic method called the least squares method, which is available on most scientific calculators. If you are using a scientific calculator in your grade 12 exam, it should definitely be able to work out the line of regression. All right. So make sure that you understand how to use your specific calculator to help you to work out the values that you need in regression analysis. All right. The linear regression equation is written as y hat, so we call that y hat with the little copy on top of the y. Y hat is equal to a plus bx, or y is equal to capital A plus bx. This should remind you, of course, of the more familiar equation of a straight line, which is y is equal to mx plus c. Now, what exactly is going on when we say we're using the least squares method? Well, what's happening is, suppose that we guess a line of best fit. Okay, so we guess at what line is going to best fit the data. Then at every data point, we find the distance between the data point and the line. If the line fitted the data perfectly, then what would happen? Obviously, all your data would then lie on the line. So therefore, the distance between the point and the line would be 0 for all the data points. However, the worse the fit, the larger the differences get. We then square each of these distances and add them all together. All right? The best fit line is then the line that minimizes the sum of all these squared distances that we found. Okay, so if we have to illustrate what that looks like, so this is what we're saying. We guess at what is the line of best fit, which is this line here that's drawn. You're then going to look at the distance between the data points and that line. And then the best fit line is the line that minimizes the sum of all of the squares of those distances. All right, I just want to remind you of some of the formulae that you will be given on your formula sheet. Your your value b, which is the gradient in your, just go back up here, in your linear regression equation, y hat is equal to a plus b times x. So b would be the gradient of your line. Okay, and that's the formula you use to work out what the gradient is. And this is the formula you would use to work out the y-intercept in the line y hat is equal to a plus b times x. Okay, so that's simply reworking the formula to get a as the subject of that formula. Okay. As I said to you, we're going to go through using your calculator. I've shown this to you before, but once again, we'll go through using your calculator to work out the values that you need in regression analysis as well, to work out the values of A and B in that equation. All right. Then the other important concept we talked about in grade 12 is correlation. And we looked at what we call the linear correlation coefficient, which is given by the letter R. And this measure tells us the strength and direction of a relationship between two variables, okay, depending on what you have data on. The correlation coefficient has a range of values between -1 and 1. When R is equal to -1, that tells us there's a perfect negative correlation. When R is equal to 0, there is no correlation. And when R is equal to 1, there is a perfect positive correlation between your variables. To work out the linear correlation coefficient, you can use the formula R is equal to the gradient that we worked out before, times by the standard deviation of x divided by the standard deviation of y. Once again, this can be worked out on your calculator as well. Okay. This correlation coefficient, for those of you who want to know, this is called the Pearson's product moment correlation coefficient. And as I said, it's much easier to do on your calculator. Now, an important thing, and I've used this example before because I simply think that it just brings home the point. Correlation does not imply causation. So just because two variables are correlated, it doesn't mean that the one causes the other. So for example, let's think of an example. It's a common mistake really that's made is that correlation implies causation, which it doesn't. So for example, ice cream sales and shark attacks are correlated. So that shows that there is a positive correlation between the two. This, however, does not mean that the sale of ice cream is somehow causing more shark attacks. So the more ice cream you eat, the more shark attacks? No. Instead, a simpler explanation is that the warmer it is, the more likely people are going to buy ice cream and be at the beach, and they're more likely to be at the beach as well, thus increasing the likelihood of a shark attack. Okay, so the sale of ice cream does not cause a shark attack. Okay, so that's where you've got to be very careful on how you interpret your correlation coefficient and the variables that it relates. Okay, so I think after that discussion, you should all now remember what regression and correlation is all about. Let's look at the first question, which comes from a past paper. This comes from the June-July 2015 paper 2. It's question 2. I'm simply going to give you time here to take down the table that's drawn, okay, or to find the question paper. If you're learning from your past exam papers, perhaps you can find the question paper. If not, take down the table that's given in the question so that as we go through the question, you can refer back to the table. I'm going to give you 2 minutes to take down the table. Okay guys, so in this question it's very important to be able to use your calculator in order to help you work out the values that you need. Okay, let's read through the question and then we will see how far we get, okay? So we've got that 14 learners attended a geometry training course spread over 12 Saturdays. Learners wrote a geometry test at the end of the course. Importantly, one learner was absent for the test. The number of Saturdays attended and the mark as a percentage each learner obtained for the test are shown in the table. Now, if you go through this, you'll see that your first row shows the number of Saturdays attended by each learner and then the mark that they received as a percentage. If you were to count the number of data entries, you will see that even though 14 learners attended the training course, there is only 13 entries, and the reason for that, so these are kind of things you already need to be asking yourself, why is it? Why do I only have 13 data points when there are 14 learners? Well, remember the key thing they told you here is one learner did not write the test, so obviously they're not going to have that column complete because we don't know what that learner got for the test because they didn't write it. Okay, so therefore there's only 13 data entries. The first question says, calculate the equation of the least squares regression line. It's for 3 marks. You need to be able to do this on the calculator. It is way too long to try and work this out manually for 3 marks. All right, so remember what we're working out is this. Okay, and in order to work out the equation of any linear line, you need the y-intercept and you need the gradient. Okay. I'm going to show you how to do this on your calculator. I've already entered many of the data points in, as it's going to take too long to do them all with you on screen. But the first thing you want to do to get your calculator in the right frame, which is the statistical mode, is you press mode and you hit the number 2 so that you are going to enter all your data points. All right, I've already done that, and I'm just going to call up now the data points that I've entered. Okay, and I'll show you guys the numbers that I've entered. You'll see at my data point 1, I've entered 12 Saturdays and that person got a mark of 96. I then go all the X values, because remember here on your table, go back up here, the number of Saturdays attended, that's your independent variable, so that's X, and your mark depends on the number of Saturdays attended. So this mark as a percentage would be Y, and the number of Saturdays would be X. Okay, so in my column, the first column shows the X values I've got, 12, 11, 10, and I've entered all of the Saturdays that we were given. Okay, 10, and then we've got 11 Saturdays, and then you see the 13th entry point I've left blank, which I'm going to fill in with you now. That person attended for 6 Saturdays, and the mark that they received, so you press 6, you press equals, that will then go into row 13, and the mark that they received was 59. So you press 59 and you press equals. Once you've entered all your data points, you just clear the screen. Okay, all that information is still there. It hasn't disappeared. And we're now going to work out, well, not work out, we're simply going to recall from the calculator the value of B and A. Okay, to do that, you follow the following steps. You're going to hit Shift, Stat. Okay, this brings up the screen as you see it. What are we doing? We're doing regression, and that's represented by number 5 with the letters reg. So you press 5. When you press 5, do you see you get all the different variables that you could possibly work out? You've got A, B, R, X hat, and Y hat. What do we want? We want the value of B, so I'm going to press 2. All right, sorry, I meant to press 2 there, so let's just do that again. So it's regression, we want 2, and we press equals, and we get 5,898. So that value gives me the gradient of the line that I need. I now need to work out the value of A, which is the y-intercept. So all I do there, once again, clear your screen. You're going to hit Shift 1, which brings up the stat screen again. We're looking at regression, so we press number 5. We've already worked out the value of B. We want the value of A, so we hit 1 and is equal to, and we get 22,26 with a whole lot of other numbers thereafter. Okay, so therefore the question says, calculate the equation of the least squares regression line. My regression line is going to have the following equation. Y hat is equal to A, which is 22,26, plus B, which is 5,89. If we round that up, 5,9 times X. All right. Okay, you need to get that part right. That is the key part in this question, because all the questions that follow are going to be based on this line that you found. All right, so while you familiarize yourself with the calculator, let's take a quick break and then we'll continue with the rest of the question after this. Welcome back, guys, to our revision on statistics. We are still continuing with the question 2 from the DBE paper 2, June-July 2015. So before the break, we saw that our least squares regression line had the equation y hat is equal to 22,26 plus 5,9x. All right, the next part of the question says, calculate the correlation coefficient. Again, you'll notice it's only for 2 marks. So it's going to be the best option for you to work this out is going to be using your calculator rather than going through by hand method. All right, so to work out the correlation coefficient, which is R, so on your calculator, once again, we've got all our data values there. We're looking for the correlation coefficient. Once again, we go into our stats form of our calculator screen. Okay, we want to look for regression, so we press number 5. You see that the letter R is given at number 3, so I press 3 is equal to, and I get 0,9205 and so on. So we can round down to R is 0,92. Okay, so that's our correlation coefficient. They haven't asked us any question on that yet. However, the next one says, comment on the strength of the relationship between the variables. Now remember, the variables you're examining here are the number of Saturdays attended for this geometry course and the mark that the learners get, okay? And we saw that the correlation between those two is a high positive, close to 1 number. It's 0,92. So therefore, to comment on the strength of the relationship, there's a strong positive relationship between the number of Saturdays attended and the mark obtained. All right. Okay, let's have a look at the next one. So here we've got that the learner who was absent for the test attended the course on 8 Saturdays. Predict the mark that this learner would have scored for the test. And this is where working out the equation of least squares regression, working out the equation of that line is so important, because it can help you to make predictions about values that are not given in your data entry points. All right. So we know that this learner attended for 8 Saturdays. We were told that we don't know what his mark is. We haven't been given information about that. So to predict the mark, all we do, this is 1.4, we've got our equation, which is y hat is equal to 22,26 plus 5,9 times x. I know that x, which is the number of Saturdays that this learner attended, was 8. I'm simply going to substitute that value in place of x, and I'll get that the approximate mark that they will get. You can, of course, keep all your values on your calculator and then simply work out your value, your estimated value, using the values that are already contained on your calculator. All right, so we've got 22,26 plus 5,9 times the number of Saturdays, and we get 69, so this is approximately 69,46%. Okay, so you can say that this learner got 69%, and you base that prediction on the fact that you worked out what this equation of your least squares regression line was. All right, guys, I think it's time for us to look at another question. So let's have a look at the next one, which comes from DBE Maths Paper 2. November 2015, and this is question 1. Again, I'm going to give you some time just to either find the paper and find the question, or to take down the table, because we'll be working from the table for the remainder of the question. And I'm going to give you 3 minutes to take this down. Right, guys, so the first question here talks to us and asks us about a scatter plot. Now, remember, a scatter plot shows you bivariate data, so it's two different variables that you are comparing, and you can then compare this using a scatter plot. All right, let's read the question. It tells us that the table shows the total fat in grams rounded off to the nearest whole number, and that's in your first row. And it shows you the energy in kilojoules rounded off to the nearest 100 of 10 items that are sold at a fast food restaurant. Okay, so if you count your number of data entries, there should be 10. The first part says represent the information in a scatter plot on the grid provided. So this is given to you in your final exam. You are given the grid paper, and remember, scatter plot, you're literally taking each point and you're plotting the coordinate. The fat in grams will be your independent variable, and the energy will depend on the amount of fat, so that will be your dependent variable. All right, so I've already plotted these points for you so that it's easier for us to go through this question together. So for example, when I look at fat, of 9 grams, I see that the energy released is 1,100 kilojoules. So on your grid, on your graph paper, you'll see where we have a value of 9, so where the x value or the fat value, okay, and remember you must label your axes. So the energy is on the y-axis, the fat in grams is on the x-axis. So when the fat content was 9, right, you saw that the energy released at that point was 1,100 kilojoules. All right, so that's where the two meet, that's where we put a dot. We go through the rest of the points in the same way and plot each of them. Let's take one further into the table. So let's take when the fat content is 29, the energy released is 2,600 kilojoules. So I'll go to 29 on my horizontal axis. So 29 is just before 30, so it's that one there. We go up to where it meets 2,600 on the y-axis, all right, which is your kilojoules released. And where those two meet, the point 29 and 2,600, we put a dot. All right, so this is roughly what your scatter plot should look like. I can't fit everything into the screen there, but hopefully you all have the same graphical representation of your scatter plot as well. All right, so let's have a look at what the rest of the question says. So it's the same question. It's coming from November 2015. It's question 1, and we're given the total fat and the kilojoules released. Now 2.2 says, the equation of the least squares regression line is given as y hat is 154,6 plus 77,13 times x. Okay, so they've already given you the equation of your least squares regression line. So the first part that's based on that question, 2.2.1, an item at the restaurant contains 18 grams of fat. Calculate the number of kilojoules of energy that this item will provide and give your answer rounded off to the nearest 100 kilojoules. So you've got to first understand what it is that they're asking you for. Obviously, you know that there's a relationship between the fat content and the energy released. They've now given you the amount of fat and they want you to estimate or to calculate what the amount of kilojoules released will be. So what are they asking you for? Well, in your equation of the least squares regression line, they're asking you for what the approximate value of y is. All right. So all we're going to do there is simply substitute our x value as 18 grams and work out what the amount of energy released is. Okay. So we're going to go 154.6 plus 77,13 times by 18, and that gives us 1,542 kilojoules. But remember, they said round off to the nearest 100 kilojoules. So that actually means I've got to take 1,542 and round it down, because the closest 100 kilojoules would be 1,500 kilojoules. All right. Okay, the next one, draw the least squares regression line on the scatter plot drawn in question 2.1. So what you would do there, remember you've already got your scatter plot drawn. You've already got the equation of the least squares regression line. It was given to you. So you're simply going to draw that line onto your graph paper. So it's going to look like this. So I've simply taken the equation of the least squares regression line, all right, and I've put that over by using whatever method you use to draw a straight line, gradient intercept method, or you use your dual intercept method. The quickest way that you can draw this one is probably gradient intercept method. You will then take this line that they gave to you, which is 154,60. Let's just write this on this side. All right, we've got to swap between the two screens, so it's a little bit tricky. 1,54,6 154,6, sorry, plus 77,13 times x. So that's the line that we have drawn in and superimposed on our scatter plot. All right, guys, hopefully so far your diagram is also looking in a similar. All right, I think there's a little bit more to this question. So what I want to do is I just want to give you 2 minutes once again to just read through the last bit of information that you've got to answer questions on. We'll come back after the break and do this together, but 2 minutes just to read from 2.3 onwards. Okay, guys, as you work this question out, we're going to go into a break to give you some time to work through this question based on what we've already calculated in part 2.2 of this question. I'll see you after this break. Welcome back, everyone. Just a reminder that we are looking at statistics revision today, and so far we've looked at 2 questions from a past paper that have been based on regression and finding the correlation coefficients, and we also drew a scatter plot as well just before the break. All right. Now let's go through the question one more time and then answer the last part of this question. Reminder that this comes from your Maths Paper 2, November 2015. This is question 1. So you were given the table which shows the total fat in grams rounded off to the nearest whole number and energy in kilojoules rounded off to the nearest 100 of 10 items that are sold at a fast food restaurant. So you had your fat being the independent variable and the energy in kilojoules was your dependent variable. All right. 2.3 says identify the outlier in the set. Now remember what an outlier is. An outlier is a value that almost doesn't seem to make sense with the rest of the data. It's either really small or it's really, really a big value. So it's one that doesn't quite fit in, okay? So it's an extreme value. So you've got to look through your data that was given to you in this table and see if there's any value like that that exists in this question. So when I look through the table, I see that the one value that really just leaps out at me, and hopefully it also leaps out at you as well, is this one. We've got that one there where your fat in grams is 8 grams and the amount of energy released is 300. Now, if you compare that to the other values in your table, you will see that that 300 kilojoules is way smaller than all of the other kilojoules or energy released. All right, and it almost doesn't seem to fit in, because if you look at 9 grams of fat releasing 1,100 kilojoules, and then 8 grams, which is only 1 gram less than that, only releases 300 kilojoules. So the outlier in this set will be the point 8 and 300. Okay. 2.4, calculate the value of the correlation coefficient. Now this one is very interesting, because in this question you didn't have to work out the equation of your least squares regression line. Remember, if I go back and show you, this was actually given to you. So in part 2.2 of the question, they gave you the equation of the least squares regression line. You didn't have to work it out. And now they're asking you for the correlation coefficient. So it's interesting. What do we do there? Okay, there's different ways that you could work this out. The one thing that you might decide to do is, well, remember that B, or look at your formula sheet and see that R is given by the following. B, which is the gradient of your least squares regression line, times the standard deviation of X divided by the standard deviation of Y. So you might decide, okay, well, I can then work out the standard deviation of X and Y by entering these values into a formulae and then working out what the standard deviation of X is and what the standard deviation of Y is. Certainly you can do it that way. Now the way I would prefer to do it is to enter the data points into the calculator and have the calculator do the work for you. Remember, this question is only for 2 marks, so probably the quickest way to do it would be to enter your data points into the calculator. Let me once again show you how you would do that. So you call up your calculator. You want to find out something about the regression and the correlation coefficient, so therefore you go hit mode and you're going to press the number 2. All right. When you press the number 2, you will be able to enter your values for X and Y. Now that I've already done, okay? And I'm going to show you what the data points look like. All right, so you will get 2 columns, well, 3 columns, the one showing you the number of data points, and then you've got the values for X and Y. And what you'll see is I've entered values for X being the fat content, and then I've gone all the way to the 10th data point, which was when X is 20, the amount of kilojoules released is 1,600, and I've gone through each of those points and entered their X and Y values. Now, straight from your calculator, you will be able to then work out your correlation coefficient. So what you would do is you would say, well, R is equal to, you press the following set of buttons. So you start with Shift, you press the Stat button, which is the number 1 on your calculator, all right? And then you'll see that you get a screen that says type, sum, data variance, min, max. What are we interested in? We're looking at regression, right? So we press the number 5. And then when you press the number of 5, you get different options. You get 1 showing you what the value of A is, 2 being the value of B, and 3 being the value of R. And in fact, remember, they gave you, while we're just on this point, because you can always, if this was a question that you had to do from scratch, you could check and double check that your answer is correct by using your calculator. Or if you wanted to verify that this line was in fact given by 154,60 plus the gradient is 77,13 times X. You could indeed then just use your calculator to confirm that those are indeed the values for A and B. So if I press 1, I get the value for A as 154,60. And then if I go back through the steps and I press Shift 1, again looking at regression, and we want the value of B, which is the gradient of our line, we hit the number 2, and that will give us 77,13 rounded up. All right, so therefore we can see that this is in fact the correct equation that matches the line that they gave us. But what we were interested in is the value of R. So again, follow the steps. We hit Shift 1. We're looking at regression, so we press the number 5. Now we want the correlation coefficient. which is given by the letter R. So we press 3 is equal to, and we get 0,952. All right, so from your calculator, you're simply going to read off the value 0,952. Okay, so that's the value of your correlation coefficient. And guys, this is why I'm saying to you, it is so much better to be able to work all of this out on your calculator than to struggle through doing it by hand. Why is it so much better? Often these questions are for minimal marks, 1 or 2 marks. It doesn't require you spending too much of time on each of these questions. So therefore, when you see your questions for 1 or 2 marks, chances are the best way to do it, the quickest way to do it, is going to be by using your calculator. All right. Now we've answered part 2.4, calculate the value of the correlation coefficient. We've got that R is equal to 0,952. 2.5, comment on the relationship between the fat content and the number of kilojoules in energy. Okay, well, here we need to remember, okay, so we can see that R is 0,952. Remember that your correlation coefficient will always fall between the numbers -1 and +1. It will be some value in that range. -1 tells you, R is equal to -1 tells you that you have a perfect negative relationship, or if R is equal to +1, you've got a perfect positive relationship. All right. Now, when R is equal to 0,952, you see that that value is very close to the +1 value. So that tells me, therefore, there is a strong relationship, strong positive relationship between the fat in grams, or between the fat content and the amount of energy released in these foods. Okay, so that's really all that you can get from this value of your correlation coefficient, is that there's a strong positive relationship between the two values. So make sure that you understand how to work out your values for R, A, and B using your calculator. That's key for you guys to remember. Now, say that some of you didn't remember that you could go through this process and work out the regression on your calculator. You could, well, to work out your correlation coefficient, you could have then decided, okay, well, they've given me the gradient of the line. Okay, they gave it to you. B was equal to 77,13. You could then work out the standard deviation of the fat in grams, and you could then work out the standard deviation of energy in kilojoules. So you could work out each of those values, take your standard deviation of X, divide it by the standard deviation of Y, and then multiply it by the gradient, and you would come out to exactly the same value of your correlation coefficient that we got just plugging the values into the calculator, obviously provided that you didn't round off anywhere or make any careless mistakes. All right. Okay, so the important concepts and the important things that we learned in today's lesson, and I'm just going to go back here and just recap what we talked about at the top of the lesson. We saw that when we talk about linear regression, we saw that this was a technique to find out exactly which linear function best fitted a given set of data, as we saw from the examples that we did. We know that the linear regression equation, which is y hat is equal to a plus bx, can be actually worked out on your scientific calculator with minimal effort from you, okay? You've just got to know how to work out your calculator. And how does the least squares method work? Well, it's very simple. All we're doing is we're guessing at a line of best fit, and then every data point, we find the distance between the data point and the line. If the line fitted the data perfectly, that distance would obviously be 0. So we went to our diagram, we said if this was a perfect relationship, all these data points would actually sit on the line. All right. And the method that we're using, this sum of the square distances to work out the best fit line, what we do is we square the distances between the data point and the line, we add them all together. The best fit line will be the line that minimizes the sum of the squared distances, okay? And that was really the key concept that you learned in grade 12 and that you will be examined on at the end of the year. So my advice to you here, remember, as we talked about in the beginning of the lesson, don't learn your formulae off by heart. Rather focus your time and effort on studying the important concepts for your stats part of your exam, and make sure, most importantly, that you know how to use your calculator to help you work out your regression line and then also your correlation coefficient. All right, guys, good luck with your studying. Until next time, cheers.